Hello, welcome to 𝐘𝐥𝐬𝐬 classes. My name is Professor Vivek Singh Rathore and I am Assistant Professor in Electronics and Telecommunication Department in Government Engineering College, Bilaspur, Chhattisgarh. And in this video lecture series, I am taking Signals and Systems subject for upcoming GATE examination and Engineering Service examination also. So, in this we are going on in Module 10 and this is the 10th lecture, and I have almost completed many types of signals, classifications of signals. What are the various operations which are performed on signals, that we have almost completed. Now from today's lecture will start classifications of system. So systems are also classified because see, whenever a signal is applied to a system, some output is coming. Okay, so how does we classify these type of systems? Okay, so first we need to understand what does this system does, what work it does, and then we can classify that. Okay, this is doing it is doing some linearity, or it is a time variant system. Means whenever we change the time of input, it produces some other output. So on the basis of these all factors, we will classify the systems as different type. So let's get started, and we'll write our first we'll need to understand what is actually our system. Okay, so we need to see we are applying some input here. Okay, and we are getting some output. Let's suppose this is our xt, and we get output as yt. So this is our system. Okay, this will represent as s. Okay, so this system, what is it? It is a some mathematical entity. You can say a mathematical expression or mathematical expression, let's suppose. Okay, what it does, it maps, actually it maps input to output. Okay, so we can say it maps input to output. Okay, so if a system maps set of continuous time signal to continuous time output, then that system will be called as continuous time system. Simple concept is there. See, any system can be defined in many type, like how it can relate your input signal to output signal. A system is having what type of physical composition. Okay, we can also express our system as differential equation, difference equation if it is in discrete time. Okay, and a system can be also represented as unit impulse response. Whenever we give unit impulse input, and the output what is there, let's suppose for unit impulse input we get output as this. So this is called as impulse response, because input we have taken impulse. Whenever we give ut input unit step, we get some response, we'll call it as step response. Okay, so we can classify systems on the basis of this also, and we can classify systems on the basis of transfer function also. Okay, transfer function is the ratio of output by input keeping all initial conditions 0, and we can state our systems in terms of state variables also. So systems can be defined as in many types. So let's see, we have some systems property also, and on the basis of property it is classified also. So we'll see first type of system. Okay, first type of system is linear and non-linear system. Linear and non-linear system. Okay, so linear and non-linear systems, you can see from the figure also. Linear and non-linear, for a system to be a linear, and for a system, from diagram only you can understand how linear system works and how a non-linear system works. Okay, so you can see from this figure only. So for a system, because see, if you are giving a input to a system and you are thinking that this system is linear or not, it is producing like this and or it is producing like this. So system is linear or not, you need to check two conditions for linear or non-linear system. That two conditions are, one condition is homogeneity principle, and second condition is for superposition principle. Okay, so this two condition you need to check. If both are satisfying, then only system is called as linear system. So how we can check homogeneity and superposition principle? See, one system is there. Okay, one system is there, and if we are giving input as xt and we are getting output as yt for this type of system, if the same system we are giving input as a into xt, okay, for the same system, and if we are getting output as a into y of t, okay, for the same system, if we are giving input as xt, we are getting yt. But if we are giving just any multiple, we are doing multiply and we are putting the same signal, and if output is coming as same output, only a is multiplied, this verifies homogeneity principle. Okay, so this satisfy homogeneity principle. Okay, now see, let's do some other second superposition principle. If you have applied to a system a signal and output is there, let's suppose x1 t is your input and system is there, and you have got some output y1 t, let's suppose. Now for the same system, if you are applying x2 t, okay, and if you are getting output as y2t for the same system, now whenever you apply, if you will apply for the same system, like see, this system is the same thing, both are same, and now you are applying x1t plus x2t, means what you are doing, you are combining these both signal and giving input to that system. If you get output as y1t plus y2t, it means combination of this output, then definitely you can call it as that you can verify that this satisfy superposition principle. This satisfies superposition principle, and those system which verifies or satisfy both the principle are said to be linear systems, are said to be linear systems. Okay, if it does not verify at least one of the principle or both the principal, system is called as non-linear system. So it should satisfy both the principle for being linearity. Okay, so let's take some example and we can understand how linearity and non-linearity works. So see, we'll take some questions. Let's suppose you have been given question as yt is equal to 5 of xt, let's suppose. Okay, now see what is happening. You first understand what system is doing, then you can understand it is linear or not. So whenever we are giving input xt, our system is what it is doing, it is multiplying it with 5 and output is coming as yt is equal to 5 into xt. Simple concept. So if you multiply with this system, same with this system, if you multiply a into xt, what it will do, it will just multiply 5 in front of it, so yt will come as 5 into a xt. So can you say that it is 5xt, it is 5xt and just a multiplied? So you can say it as now you can say it as that it satisfy homogeneity principle, it satisfy homogeneity principle. But now what will happen, see, second condition we'll see, if we are giving the same system which is multiplying 5 with it, so x1t, if you get, will get y1t as 5 of x1t. Okay, now if same system you will give input as x2t, it will again multiply 5 and it will create y2t is equal to 5 of into x2t. Now in this same system, if we add both signal and will send it x1t plus x2t, so it will again, it will, what it will do, it will just multiply 5 and it will create 5 x1t plus x2t, that much only. So you can see 5 x1t it is y1t plus 5 x2t it is y2t. So if we are giving input as summation, we are getting output as also summation, so it satisfy our superposition principle also. And if both condition are satisfying, it means it is a linear system. So many systems are there which are linear. See, one more example we'll take. I have taken linear system, we'll take some non-linear system also. So we'll take one more example. Let's suppose yt is equal to x square t. Okay, yt is equal to x square t. Now what we need to do, see, if in a system, we are giving input as xt, what it is doing, it is just squaring the input. So we are getting output as y is equal to a into x square t, sorry, yt is equal to x square t. Now if we are giving input it as a into xt, what it will do, whatever input will come, it will just square. So yt will be equal to a xt square. So it will come it as a square x square t, which is not equal to this condition, this both. So it is not satisfying our homogeneity principle. And if one condition is also not satisfied, we do not need to check another principle, and this clearly tells that this is a non-linear system. Okay, one more example we'll take, we'll understand exactly what it is showing. So again, one question will take, yt is equal to, let's suppose, 2xt plus 7 will take. Okay, so see, one system is there. Okay, what it is doing, whatever input is coming, it is multiplying with 2 and adding with 7. It is doing like this only. So xt is equal to 2xt plus 7, output is there. Okay, while t is equal to, now if you multiply a with xt, what it will do, it will just do again, whatever comes input, it will multiply 2 with the input and just add 7. So you can see, if this will be equal to, this should be equal to this one, but see, yt should be equal, this one should be equal to here a into yt actually. Okay, so a into yt, if you do a into yt, if you do, you will get a into yt, a multiply, so 2 a xt plus 7a, है ना? If you multiply here a, so you'll get like this value, but you are getting this value. So these both are not equal, so these both are not equal. So ultimately this system does not follow homogeneity principle. So if it is not following homogeneity principle, it is also non-linear system. So from this example we can conclude that this is a non-linear system. We'll take some other examples also, so that you must be comfortable in just judging a system is linear or not. So we'll take one more example for that. See, example is there, yt is equal to, let's suppose, x of minus t it is given. Okay, so we need to check it is linear or not. So we'll see homogeneity and superposition principle. Yt is there. First we need to, once we need to calculate a of yt also. See, by making such diagrams, it will take time. So first you need to calculate a into yt. So a into yt means a into x of minus t. Okay, now what we'll do, we'll give a into xt. See, this system is there, let's suppose this system is there, and what is it is doing, t minus t it is just doing. So we are getting yt is equal to x of minus t. Okay, this much only. So now what we'll do, we'll give input as a into xt. What it will do, yt will be, it will create a into a only and x of minus t. So see, a into yt and for output of axt should be same. Okay, so it is not, it is exactly equal to same, so it is satisfying homogeneity principle. And now again we will take x1t. Okay, now for this what we will do is y1t and plus y2t we will do. So it will come as x1 of minus t plus x2 of minus t. Okay, so let's suppose x1t plus x2t. If we give input to this system, it will create output as x1 of minus t plus x2 of minus t, and it is exactly same as y1t plus y2t. So what we will get, it is satisfying superposition theorem also. So it is also linear. Now we'll take some another example also, like what should we take? We'll take one more example, like see, some non-linear example. Yt is equal to e to the power xt. E to the power xt. First we should do multiply also a into yt also. You should calculate now only. So you will get a into e to the power xt. Okay, and for system we need to see what it is doing. It is doing just input you are giving e to the power xt. It is doing whatever input is there, it is taking exponential of that. So yt is equal to e to the power xt, it is there. Okay, now if you give input as a multiplied by a xt, if you will give, output will be yt is equal to a will be there, oh sorry, e to the power, it will take exponential of whatever input is there. So e to the power a xt will be there. So it will be e to the power a into e to the power xt, which is not equal to a e to the power xt. So here only it is not satisfying our homogeneity principle, so it is not a linear system. Okay, now some more example we'll take and we'll try to solve, like this question is there. um, Okay, I think x of t square is linear system. If you tell x of t square, it will see. After solving many questions, we will come to know that if there is nothing in x square or something, if it is x value only inside whatever it should be, x t square or x of a t. Now we have just solved x of minus t. It's there. Anything is there, it will be always linear only. It will be always linear. We have already checked for x of minus t. You can check for x of at and x of t square. It will come linear only. But when it will come non-linear, I'm telling you, now only we have seen 2xt plus 7 है ना? Some values are there, x square of t, some different multiply signal is there. Okay, and now we have seen e to the power xt. Okay, these type of signals are in general are called as non-linear system, and I have told you how to solve it, because only this method is there. You need to check homogeneity, or you need to check and you need to check superposition theorem also. So like this type of signals are there. Now see, if I tell you log of x of t, if I tell you and I will ask you, is it signal linear or non-linear, you'll just see something is there for xt also. So it should be non-linear, but we'll check also. See, we'll take a into yt also once. So a into log of xt is there, and we'll do xt is there. It is coming log of xt. Okay, if we are giving xt input, this is creating log of xt. If you will give input as a into xt, what it will give, log of a into xt, which is not equal to this a into yt. So it is not satisfying homogeneity principle. So there only we can say that it is a non-linear system. So these all type of signals are there. See, one last example I will take you. Question, yt is equal to t into xt is there. Okay, t into xt is there. Now you will tell, okay sir, this is multiplied with this, so it is a non-linear system. No. There should not be multiply of x somewhere. Okay, so you can calculate it also. A into yt, just you can do a into yt is t into xt, and if you are giving input as xt, okay, and you are getting as output as t into xt. If you will get input as a into xt, what we will get output as a into t into xt. Okay, so see, a into t into xt, a into t into xt, both are satisfying. It is homogeneity principle. And if you will add also a into sorry t into x1 t plus t into x2t. This is y1 plus y2. If you give x1 plus x2 also, and x1 plus x2 also will give input, will get output as a into a into t into x1 plus x2, which is equal to exactly it's not a only t into x1 plus x2. You'll get like this. So definitely it is satisfying both homogeneity and superposition. So this is also a linear system. So in this video lecture I have explained you in deeply that what is actually linear systems and what are non-linear systems, how we can justify or we can judge that it is this system is linear or not. Okay, so I think non-linear system, whenever you give input, it will create periodic output or quasi-periodic also it can create, but it will be a non-linear in nature, like subharmonic, chaotic and something. So this type of systems are called linear and non-linear system. So we'll meet in the next lecture and we'll see what are time invariant system and time variant system. Till then, tata, bye bye, see you, have a good day, jai hind, jai bharat. Okay.